Real depth and apparent depth of a tank. Now let us understand the phenomena that you also have observed in your daily life, that when you put some coin in a glass of water, it appears to be raised up, or a water tank or water bucket, it appears to be shallower, means that appears to be rises up somewhat. Now what is the reason behind that, and what is the actual depth and what is the apparent depth, and how could we find out? Okay, so now to find out, let us consider this O position. This is the water tank and this is air having refractive index mu A, and this is suppose water tank having refractive index W, mu W, which represents the water. Okay, now let us consider the object is at point O, and when a ray goes straight, okay, normal to the interface, it passes straight, as it does not suffer any refraction, does not show any bending of light. So one ray which is going up will passes straight. And let us consider another ray is incident at an angle of incidence I. Okay, when it goes from water to air, means it is going from denser to rarer medium. So in that case, it will bend away from the normal at an angle of R. Now since this angle is I, so this angle is also I, and since this angle is R, so this angle is also R. So we can write that angle A, that we represent the name as B. Okay, and this is C. Angle AOB is equal to angle, this is OBN. Okay, OBN dash is equal to angle I. Similarly, we can write as angle NBC is equal to angle BIA. Angle BIA is equal to angle R. Now in triangle OAB, this is OA and B. This is the triangle in which this angle is I and this is 90 degree. So this becomes base, this becomes perpendicular, and this becomes hypotenuse. So in that case, we can write sine I is equal to perpendicular upon hypotenuse, that is AB upon ON. Okay, AB upon OB, sorry, this is OB. This is sine I. And similarly in triangle AIB, this AIB, this is the base, this is perpendicular, and this is hypotenuse. So sine R can be written as perpendicular, which is AB, upon hypotenuse, which is AI. Now since we represent number 1 and number 2. Now since the light is going from rarer water to air, okay, so applying the Snell's law at this point, we can write mu W into sine of I is equal to mu A into sine of R. Okay, so in that case, sine R upon sine I is equal to mu W upon mu A, which is equal to A mu G, reverse order. Okay, so we can write as A mu W, water, here water, is equal to sine R by sine I. This is sine R by sine I. Now what is sine R? This is AB by AI into, this is AB divided by A, so this is AB into OB. AB to AB cancel out, so we'll be having OB by AI. Now assuming that this point I is lying very close to O. Okay, so in that case we can replace, what we can replace here, the value of OB, B can be replaced by A. Means if we can say that this point B is lying very close, because when you see from the upward, okay, there is not much distance between the two eyes. The rays that is entering to your eyes is not so far for making an image. So since B is lying close to A, so we can replace B by A also. So in that case we can write as, this is OB. OB is what? This is OA upon AI. Now OA was x, which is actual depth, and AI was y, which is apparent depth. So we can have A mu w is equal to x by y. So from here we can get the value of y, which is equal to x upon A mu w. So this is how we can get the value of apparent depth of a container, of a water tank, of anything.